Well, good morning, good afternoon, good evening to everyone who's joining this session today from wherever you are in the world. I'd like to thank you for taking some time out of your day to learn about how to build a better virtual desktop. Now, before we begin, I just want to say that this is a virtual VMUG event. It doesn't have quite that same interactivity level that we would have if this was a normal VMUG UserCon or an in-person VMUG event. So if at any point you have any questions, please feel free to drop them into chat where we will get to answering them. So my name is Sean Massey. I'm a Staff Cloud Solutions Architect with VMware. I am part of our worldwide cloud practice, and in that group, so that group is basically supports our cloud provider partners and our hyperscaler partners. Inside that group, I focus on end user computing. So I do cloudy EUC things. I'm a VCDX, and I'm based out of Wisconsin. And on screen here, you'll see my blog, LinkedIn, Twitter. In addition to these, I'm also very active in VMUG. I'm involved in the Wisconsin VMUG as a member of the steering committee, and I really enjoy getting the opportunity to come present to you today. So why do we care about building a better virtual desktop template? So crafting a template VM for Horizon is one of the most critical steps in any end-user computing project. And this is going to have the largest impact on user experience. In fact, this is going to make or break your project. If you don't have a good template, you won't have a good user experience, and you will get users who will reject the platform. So also in our modern, era of Windows 10 with frequent Windows releases, you are going to be doing this frequently. So it's important to have a good process in place, and then to help drive, cost and efficiency or cost down and efficiency up as you will be building these templates more frequently. So before we begin talking about how to build that virtual desktop template, let's talk about a brief history of Windows in the enterprise. And our story will go back to August of 2001. And that's when Windows XP was released. Now, Windows XP wasn't the first professional version of Windows. I mean, that kind of comes from the NT line. It wasn't the first overall popular version of Windows. I believe, 95, 98 SE kind of had a lot of popularity, but this was the first version of Windows that took that stability of the Windows kernel and brought the user experience of the Windows 9 X line and brought them together. And it gained a lot of traction in the enterprise. Now, after that, we fast forward to October of 2009, where we come across Windows 7. And that was the next major release of Windows. In fact, that arguably the most popular release of Windows in the enterprise. Now, Windows 7, has had 10 years of support, which just expired back in January of this year. Although there is the option for paid security support until 2023, or if you use it in Windows Virtual Desktop on Azure, you get that support, extended support as well. Now, the next release was Windows 8.1 in October of 2013, and I would argue that this wasn't as popular or as widely adopted as 7, but it was that next one that was, stable and essentially enterprise ready. And it also has 10 years of support. Now, we didn't go, between XP and 7 directly, right? There wasn't this 8-year gap in releases of Windows. And, even with that gap, it wasn't like as soon as 7 came out, everyone dropped XP. So there were intermediate versions. And then there was this kind of life cycle where it took a while to go from XP to 7. And many organizations had these multi-year projects to validate that everything would work, that the hardware was compatible, that applications would run properly, and so forth. And so once they went through that effort, they weren't going to, just jump off Windows 7 for something new. So, as I mentioned, there were intermediate releases, and you were probably thinking, but hey, wait, where's Vista? And so, between XP and 7, we had Vista, and, we all remember that. And then between 7 and 8.1, there was Windows 8, which is probably most widely remembered for removing the start menu. And so we kind of have this alternating cycle, this really popular, really stable version of Windows, followed by one that wasn't necessarily stable or changed something big that made it not suited for the enterprise. So we kind of have this alternating tick-tock cycle. And when we think about, this tick-tock cycle of good, bad, repeating, and we think about the word enterprise, well, obviously the first thing that comes to mind is Star Trek movies, right? And we had this alternating cycle of good or popular and maybe not so good or not so popular. So you think like Star Trek II, The Wrath of Khan, really good. Star Trek IV, The Voyage Home, really good. Star Trek V is, well, kind of the Vista of Star Trek movies. Now, over time, this pattern does break down. It doesn't continue good, bad, going on forever, but there is something that comes along that eventually changes it, right? There's a re-imaging of that. And Windows 10 essentially re-images and changes the way we think about how Windows is released going forward. So if we were to compare Windows 10 to Star Trek movies, well, it's the J.J. Abrams version of Star Trek. It's shiny, it's new, it kind of changes everything about, Star Trek and how it's viewed. And, well, that's kind of like Windows 10. So now let's segue into Windows 10 and talk about that a little bit. So with Windows 10, we kind of move away from, these major releases every couple of years, and this closed beta model, and we have what they call release channels. Right, so there's 3 release channels with Windows 10. The first is the Insider Preview channel, and this is essentially a pre-release or beta channel. Right, there's 3 branches in here. There's Dev, which is what they call the fast ring. There's Beta, which is more of the slow ring, and then Release Preview, which is just before the new version of Windows is released, so IT can test. Now, with this, there is these are essentially opt-in only, and you can choose to opt into the specific channel that you would want based on your needs. So depending on what you're doing in-house, you may have people who opt into the dev or the beta channel if they're doing software development and they want to test their apps to ensure compatibility going forward. Or you may just have some people in IT who opt into the release preview channel, so that way before the major release, they're able to test things either themselves or on test hardware in a lab. Now, the the insider preview channels are rolling builds. So as new releases as new builds are generated, they are released depending on the channel you're in. Now, the next channel is the semi-annual channel. The semi-annual channel is a production branch of Windows 10. This is the main release. Now, this is released twice per year, usually once in the spring, once in the fall. And this is what you would deploy to most of your machines. This is what Microsoft recommends. Now with this, the monthly updates, the monthly patches, what they call critical updates, are applied automatically. The feature updates, that twice per year release, can be deferred for up to 12 months. So you have some time to determine whether or not you're going to deploy it. Now the semi-annual channel does have a support matrix that goes with it. And depending on the release, it may be supported for, 12 months, 18 months, up to 30 months. Now, the third and final Windows 10 release channel is the long-term servicing channel. This is the mission-critical branch, and it's only available to customers that have Windows 10 Enterprise through a volume licensing subscription. Now, this branch is really geared towards things that are fixtures or things that need to stay on a specific code base for a long period of time. So this can be things like factory floor equipment that has a PC to control that equipment. This can be medical equipment, voting machines, ATMs, those things that you need stability on. And you can't necessarily be having Windows patches that would break that would break that application. So for these, critical updates can be deferred indefinitely. There's no requirement to apply a patch. Feature updates for these are not applied automatically like they are with the other two channels. These actually have to be done manually through an in-place upgrade. Now, this kind of harkens back to the old in-place upgrade process where you would actually have to drop the CD into the drive and manually start it. Now, the long-term servicing channel is a stable snapshot of the semi-annual channel. So this is released every so many years, and it aggregates all the updates from the previous semi-annual releases. Now, because this is a stable snapshot, this lacks things that you may normally find in the semi-annual channel, such as the UWP apps or the modern apps, the store and any apps that are distributed through that, and Microsoft Edge. So really, when it comes down to it, Microsoft recommends that semi-annual channel is the one that you should deploy for most of your users, and that long-term servicing channel is only really supposed to be geared towards those fixture type equipments, which means we don't recommend using long-term servicing channel in VDI, although it is supported. So what does that servicing model look like? All right, so if you look at this graph up here on the screen, you'll see that there was always a big lift to go between versions of Windows, and these tall pillars represent the major releases. So on here you'll see things like XP closer to the left side of the screen, Windows Vista, Windows 7, 8. Well, when you get to 2015, you'll see that first tall pillar for Windows 10, and then after that we see all these smaller bars for the different releases. So the servicing model is changing to more frequent releases, and what this does is once you get over that hump of getting onto Windows 10, you don't have to do all these major projects to go to the next version. Now, you still will need to test, obviously. Microsoft is making changes, they're adding features, and that, yes, may break some things, so you do have to test, but you don't have to test everything because there is now a standard that everything should fit to. And you develop against Windows 10, it should run against any version of Windows 10. If you develop, your hardware driver against Windows 10, again, it should run, so you don't have to do as much major testing, as opposed to going from like XP to 7, where due to the time difference between when they were released, you would have to validate every application. You have to validate all your hardware. You have to validate your deployment model, etc. So I mentioned earlier that the semi-annual channel did have a support matrix on it. This chart here shows everything up through the current release that came out in May. And it shows the support lifecycle for those releases. And you'll see that depending on which version of Windows you're deploying and which release train you're on, there are different support dates. Some have a longer support lifecycle than others. Again, that depends on whether or not you're using the like Pro versus Enterprise and which specific release. Now, one thing I do want to call out here is the LTSC channel. This is not released with every Windows 10 version. This comes out on a regular basis, and you'll see here that these have 10 years of support from when they're released. So now let's talk about Windows 10 upgrades. A Windows 10 upgrade is applied or is used to apply any of the major feature releases, so that every 6-month cadence, right, those are released. Typically, those are applied as an in-place upgrade. However, and these are done over the air typically, right? So this will be distributed through Windows Update, and it'll be applied in place to your machine. But these aren't necessarily an actual true in-place upgrade, right? What I'm essentially doing is I'm renaming my old Windows folder, I'm installing a new version of Windows, and then I'm migrating settings and configurations from the old to the new. So if you look after doing an in-place upgrade, you'll see that, for instance, you have a folder there, windows.old. In Windows 10, this typically sticks around for 30 days after the upgrade to enable you to roll back. And then I'll have a new Windows folder there as well. Now, these in-place upgrades can break some applications. Now, it's getting more rare, but things that have deep hooks into the operating system can break. And I've seen this happen with security software, with things like Horizon agents and things like that. So be prepared to test and remediate any desktop upgrades that you do in your environment. Now, feature releases can also have significant performance impacts, and we will touch on this coming up here in the next couple of slides. So if you are using Horizon with Windows 10, there are some requirements for doing an in-place upgrade. Now, we have a KB on this, KB 2148176. QR code on the screen will take you directly to that KB. This one talks about doing an in-place upgrade. So first you're going to obviously want to back up your VM or your image. Then you need to remove all the Horizon agents from that machine. At the same time, you may also want to check with your other application vendors, again, especially security software, to find out what their best practices are for Windows 10 upgrades. And you may need to remove those applications at this time as well. After you've removed all those components, you will upgrade Windows 10. And then after that upgrade completes, you will go reinstall all the Horizon agents or anything else that you removed. And then you will want to test that image to make sure everything came through. Now, this is only, I only recommend this in the case where you're doing persistent desktops, persistent full clone desktops in particular, where that user is statically assigned to that machine. Rebuilding it is going to be a major lift for them. So if you're doing non-persistent desktops, if you're doing instant clones, for instance, with Horizon 8, I would recommend starting with a new build every time you want to go to a new Windows version. Especially if you have a lot of different images, because then you won't have to test every single image and every application after that upgrade to make sure everything came through okay. The last thing you want to do is do an in-place upgrade on a Windows 10 machine that's used by 1,000 users, not test something, have it break, and then have to fix it on the fly and try to figure out what broke and how to fix it when multiple users are down. So it's just, in my opinion, better to start with a fresh install. So we do have a compatibility matrix for Horizon and Windows versions, KB 2149393. Now just realize that not all Windows 10 releases are supported on a specific Horizon point release and vice versa. So for Horizon 7 and Horizon 8, we will support recent and supported Windows 10 releases. If you are using an extended service branch release, you will get support for new Horizon 10 releases during the ESB update lifecycle. So for instance, Horizon 7.5 came out 2 years ago. Since then, there's been multiple versions of Windows 10 that have come out. As we release updates to Horizon 7.5, we also add support for the new Windows 10 versions. New Windows 10 releases will get tech preview support shortly after release. And typically, they will get full support between then and the next version of Horizon that's released, unless there is an issue that is found. So now let's talk about Horizon 10 performance impacts. Right, I mentioned a couple slides ago that every new feature release has a performance implication to it. So the first thing I want to talk about here is modern apps or UWP apps. These are Windows applications that act like mobile device apps, and they're deployed and updated from the Windows Store. Now, some are built in and deployed when Windows is installed, and these have replaced, common apps like a calculator, a photo viewer. Those are still updated through the store, but they are installed by default with Windows. Now, these are installed on a per user basis. They're stored in the user profile and tied to the machine, right? So when we say that they have performance impacts, a lot of this comes from the login process. When these apps are installed, if you're signing into a new machine for the first time, part of that login delay, in addition to setting up the profile, is actually going through and registering these apps and installing them to the profile. These can also break sysprep. So if you have apps that update during install, so you're installing Windows for the first time, you're logged in as the admin user, you're going through doing your things. If the Windows machine goes out to the store and updates some of the built-in apps, this will break sysprep. And it can be like playing whack-a-mole. As you try to run sysprep, it fails. You go through the log, you will see an error with a string that says, hey, this app broke it. You have to remove that app for the particular user where it's installed, or for all users, and then try again and it breaks another app. So you can remove these. There's a process by which you can use PowerShell or the OS Optimization Tool to remove them when you're optimizing your desktop. The next thing I want to talk about here is login performance impacts. Right, so in addition to first-time login, which can take a while as you're setting up your profile, configuring those UWP apps, there are also login performance impacts from things like OneDrive. So Windows 10 1809 changed how OneDrive setup ran, and instead of being installed by default across the board, it changed to a per user install running at login. Now, for persistent desktops, this isn't a problem because my desktop, my users got their profile, it stays on that machine. Non-persistent desktops, it's essentially a new login, first-time login every time. So this can have a huge impact on the performance of the environment because OneDrive wants to run setup, and it will spike the CPU. Now, one user logging in here and there, probably not a problem, may impact a couple of users around them from that blast radius. But during a login storm, 8 o'clock in the morning on a Monday, everybody's logging back in from the weekend. Everybody gets a brand new desktop because they're using non-persistent instant clones. Now think about what that would do to performance and user experience. Now another area that we want to look at here is background tasks. And does Windows use a lot of resources? Well, the answer to that is yes. And that's because some tasks here can take up a full core on a machine. Now that's not an issue on a physical machine where you have many cores to spread this load over. But in VDI environment, cores are shared. And some of these tasks only appear to run when the machine thinks it's idle. Now, in VDI, that processor is carved up multiple ways across multiple VMs. And so while Windows may see it as idle, right, my local instance is not doing anything on that CPU, it can't see what's happening at the hypervisor layer. So that CPU is never truly idle. And so now I have a processor that's split up, it's doing work across multiple VMs. This scheduled task goes to run. It needs a full core to do things like .NET native image generation, which can hit the system pretty hard. Well, it's going to grab onto that core, and now all those other users who are sharing it are starved for resources. So we want to make sure we turn off these background tasks. Windows services. So Windows has a lot of services, and these are long-running applications. They don't necessarily have a user interface, or they run in a method where that user interface is not exposed, and they provide functionality to the system or applications without interfering with the user. So basically, think about background apps. Now, most services are built into Windows, but applications will register their own services during install, and they utilize resources on the machine. Now, I said Windows has a lot of services, and I mean a lot of services. And so not all of these are needed for virtual desktops. And some of these things are like Hyper-V enabled services. Hardware-based services like Bluetooth. You don't really need those because you're already running in a virtual environment. There's no physical hardware to control. So there's a lot of things that you can turn off to optimize. And finally, let's talk visual effects. Windows 10 and a lot of applications have, these really nice interfaces with animations and other visual effects to give a pleasant, visually pleasing experience. Now, these visual effects often rely on hardware acceleration, and some of the biggest consumers of a GPU on a Windows machine are things like your web browsers, Chrome, Edge, Firefox, Internet Explorer, and Microsoft Office, Adobe Reader. There's a lot of things like animations and effects going on when you click on menus and things like that. Web browsers use it to render JavaScript. So we want to make sure we turn off hardware acceleration, because if you don't have a GPU present, well, you're just consuming more CPU because you have to emulate that GPU in CPU. Now, there's other visual effects you can also turn off, things like clear type fonts, transparency on windows. You can turn off your background wallpaper, and even things like displaying the contents of a window while dragging it. If you look on your physical machine, you pick up a window and you drag it somewhere, you will see, the contents of the window are still rendered. You can turn that off so all you see is a clear box, which will reduce hardware load on the system. So let's talk for a second about some of the benefits of optimizing Windows 10. So why do we need to optimize? Well, if you think about the default configuration for Windows, it's really geared towards dedicated hardware, right? It's designed to live in a world where each machine has its own dedicated CPU, RAM, and storage. So there's a lot of unnecessary things running in the background that aren't required for VDI. And in our physical world, right, our entry-level machines are ridiculously powerful even today, right? You think about a low-end Celeron laptop today is better than a machine performance-wise from 10 years ago. So by optimizing, we can do things like enhance guest OS responsiveness, improve our login times, get a better user experience. And by doing this, we can increase our consolidation ratio, so we need less hardware in order to run our environment. So if we want to take a look at true benefits of optimization, this chart here shows an unoptimized Windows desktop. And this is the first 37 minutes from login. And on the screen here, we can see that we have some significant peaks in CPU utilization, all the way up to about 6,000 megahertz for parts of this process. Now it goes up, it peaks, and it comes back down for a little bit, and then scheduled tasks start to kick in after login, where we again start to ramp up that CPU utilization. Now by optimizing, we can see our login, right? It's high burst still, but only for a short period of time. Our steady state is also very low. In fact, much lower. And I don't know how well this comes through here on the screen, but the orange is the optimized, the blue is the unoptimized. We can see that in a steady state, we're using significantly less CPU, right? We don't see that same spike for scheduled tasks, right? There's one spike in there for the optimized desktop. So we can really cut our CPU utilization for those desktops. So how do we build an optimized image? So first off, and I have to emphasize this heavily, if you are new to doing VDI, do not convert a physical desktop image to your VDI template. I know it's tempting, it's pre-configured, you have everything in there, it's the way enterprise security and the desktop team want it. but that's an optimized image for physical machines. There are tools to convert it. Even if you have something like MDT or Ghost, you can lay that image down on top and then install your agents. But guess what? You're not going to get a good experience, and you're going to be utilizing more resources than you need because you don't have an optimized machine. Now, if you run the optimization tool in there, what you're going to end up with is a desktop that may be broken because that optimization tool is going to turn off a lot of things that aren't necessary. So when possible, I highly recommend that you start from scratch. And to do that, we have a guide up on TechZone that is all about building an optimized VDI image. And it will take you through step by step. And so the QR code on the screen will take you directly to the latest version of that guide. So there is a 5-step process for building an optimized image. We start with our VM creation, Windows installation. We move on to apps and agents installation. Once we have all our apps, our agents, everything else we need installed, we can go through and run the optimization tool to optimize it. We can then generalize the image, which is basically running sysprep. And then once we run sysprep and use that to copy our profile over, we can then prepare that image for first use by finalizing it and doing some cleanup. So first we want to create our VM and install Windows. And for that, there's a couple things we want to do. Now first, we're going to want to change our network card to VMXNet 3. That is the recommended network card for a virtual desktop image. We do not recommend using PV-SCSI for the virtual storage controller. The LSI Logic SAS controller is good enough for Windows 10. There's no real benefit to using PV-SCSI there, but VMXNet 3 will provide a lot better network performance and use lower CPU than the virtualized Intel driver. We want to make sure we remove any unnecessary hardware. So out of the box, this may include the SATA controller. If you're installing from a network install like MDT, you won't need your CD or DVD drive on the VM. If you are using a bare or installing from an ISO, you will want to keep that in, and then when you're done, remove it after the fact. If you're not using UEFI BIOS, using the UEFI and using BIOS instead, you will want to go into the BIOS and remove things like the floppy drive or disable it, and then disable any serial or parallel ports. Finally, we also recommend turning off devices.hotplug. The KB on the screen, KB 101.225, excuse me, will talk you through how to disable that. Now, this prevents the user from unplugging things like their network card and rendering their desktop inaccessible. So once we have the shell of the VM created, we're going to go through and install Windows. It's a standard Windows 10 install. If you're doing UEFI, let Windows create the partitions. Don't try to create those manually because there are certain things Windows is looking for in that partition layout. Once Windows installs and you go to the out-of-the-box experience, use audit mode, which is typically Control-Shift-F3 to access. Now this is a special mode for configuring Windows desktops, right? It skips the out-of-box experience, it skips creating a new user account, and you can do all your application installations from here. And this will survive a reboot, so as you reboot, it will keep going back into audit mode until you run sysprep. So here's where you're going to do, first thing you need to do, install VMware tools, especially if you do not have a slipped streamed install that includes your VMXNet 3 network driver. But you will definitely want to install VMware tools before you do anything. So after we install VMware tools, this is where we install our apps and our agents. Now the first thing we want to do here is we want to install our agents. So this, after VMware tools, the order is Horizon Agent, User Environment Manager, and then App Volumes. Right now, if you're also using NVIDIA, NVIDIA could go in here at any point after the Horizon Agent. After we have our agents installed, then we can start installing our applications. And this is where we install any applications that will be part of our base image. When we do this, we want to make sure that we watch out for any auto update functionality that may be installed by that application. Things like web browsers, PDF readers, even some enterprise-ish applications have built-in auto update functionality, so we will want to make sure we disable that or configure that so we can control it when we do that install. Now we want to verify that our applications do not have any special requirements for VDI or being cloned. Security software and some, again, high-end applications have requirements that you'll have to follow. Check your documentation. And then if you're using OneDrive, make sure you install this in all users mode so that it installs into the program files folder and is available for all users without that per user setup. Also, if you're doing Teams, make sure you do the Teams for VDI installer, also in all users mode. Next, we're going to optimize and generalize the image. So first, we're going to run the optimization tool to customize our desktop, to optimize our desktop and turn off unneeded things. Whatever we don't do with OSOT that we may want to tune, we would want to look at using group policies to configure other behavior. So this could be things like the getting started screen, consumer experiences, etc. Things that may not necessarily be configured by OSOT. After that, we'll generalize the image. This is where we run sysprep from audit mode using a custom sysprep answer file. Before we do this, we want to make sure we remove any Windows Store applications that are not needed. This will reduce the potential of sysprep breaking. So what we do here, we remove the computer-specific information. We're essentially generalizing the image. And then we're also going to copy the administrator profile to the default user profile. So this enables us to customize that administrator profile when we're installing our applications. And then this will apply to all users when they sign in for the first time. Finally, we prepare for use. So this is where we seal the image. To do that, we may need to remove GUIDs or unregister it from a central console. Antivirus, SCCM, some other applications are notorious for this. Then we're going to clean up the image. We're going to compile our .NET framework using NGen, so we have static images, delete all event logs, delete the contents of C Windows Temp, run disk cleanup to remove temporary files and unneeded files. Finally, the last couple of steps are to finalize the image and prepare it for shutdown, so clear KMS host information. So when we deploy the template to a pool, it will grab its KMS information from DNS. We're going to flush our DNS cache, release our IP, and shut down. Now we're ready to convert it to a snapshot or take a snapshot or convert to a template. So when you're using multiple applications, you may want to think about the strategy for delivering those applications. Obviously, you don't want to bake everything into an image and have multiple images to deal with. What I recommend, if your application is going to be used by 80% of users and or it doesn't have licensing, put it in the base image, then use tools like app volumes to deliver things at a department level or at a one-off level. This is where it's a good idea to have a good use case definition to know who needs what application, so you can bundle applications together with app stacks, or if you can't use app stacks, publish via RDSH. Last ditch, the last step there obviously is if you can't do either one of those, then you may have to create another image. Finally, one-off applications are things like Visio, Adobe Acrobat, things that go to specific targeted users, and you want to use something like app volumes or RDSH app publishing to deliver those directly. So last thing I want to touch on quickly, OS Optimization Tool. We've talked about that a lot here, and this is a fling. You can get it on our Fling site that is used for assisting with the customization of Windows. And this is from Windows 7 all the way up to the latest version of Windows Server. We have customization templates to really do a best practice optimized virtual desktop or RDSH server. We have the ability to analyze and optimize, remote analysis, as well as the ability to roll back if we need to. We also have command line deployment options. So we have templates, including a marketplace where you can pull templates down. We also have some predefined templates. And in the latest releases, we have dedicated templates for different versions of Windows 10. All right, so OSOT will go through. It will clean up it will change visual effects, fix the OneDrive installer issue, change some system hardware timeouts. Then it's going to disable and remove a lot of unwanted or unnecessary things for VDI. Now you can control the changes that are being made because you can modify the templates that are being used. And finally, we can automate this through command line. So if you're using a tool like Packer or MDT to build your image, you can add this in as part of your build process. Now, I mentioned this a few times on here. Check out our TechZone site, techzone.vmware.com. TechZone is where we have all of our latest technical resources and content from the end user computing group at VMware. And with that, I'd like to thank you for taking the time to join me today. I hope that this session was very informative and that you have a great day. So thank you again.